Hey everyone, welcome to Neural Tech. Here is another question for Databricks Certified Generative AI Engineer Associate. A generative AI engineer has created a RAG application to look up answers to questions about a series of fantasy novels that are being asked on the author's web forum. The fantasy novel texts are chunked and embedded into a vector store with metadata like page number, chapter number, and book title. When a user asks a question, the relevant chunks are retrieved and provided to an LLM for response generation. Now here's the situation. The generative AI engineer originally used intuition to pick chunking strategy and its configurations. But now, the engineer wants to more methodically choose the best values. So the question is, which two strategies should the generative AI engineer take to optimize their chunking strategy and parameters? Let's look at the options. Option A, change embedding models and compare performance. Option B, choose an appropriate evaluation metric, such as Recall or NDCG, and experiment with changes in the chunking strategy, such as splitting chunks by paragraphs or chapters. Choose the strategy that gives the best performance metric. Option C, pass known questions and best answers to an LLM and instruct the LLM to provide the best token count. Use a summary statistic, mean, median, etc. of the best token counts to choose chunk size. Option D, create an LLM as a judge metric to evaluate how well previous questions are answered by the most appropriate chunk. Optimize the chunking parameters based upon the values of the metric. Now pause here. Do not jump to the answer yet. Let's understand what the question is really testing. This question is testing how to systematically optimize chunking. Not embeddings, not filtering, but chunk size, chunk boundaries, and chunk quality. So the real question becomes, how do we measure whether a chunking strategy is good? Now think about option B. Option B talks about choosing evaluation metrics like Recall or NDCG and experimenting with different chunking strategies. This means we measure retrieval performance, compare results, and select the strategy that performs best. That is a data-driven approach. Now look at option D. Option D introduces an LLM as a judge metric. This means using another LLM to evaluate how well a retrieved chunk answers a question. If the chunk answers well, it gets a high score. If not, it gets a low score. Those scores can then be used to tune chunk size and parameters. So both option B and option D directly measure chunk quality. Now let's quickly eliminate the others. Option A focuses on embeddings, not chunking. Option C uses token count from answers, which does not reliably represent good chunking. So the correct answers are option B and option D. That's it for this question. I'll see you in the next one.